Why don't we get started? Welcome, everybody. This is a little bit out of turn. I forgot. I hope you aren't too disappointed that it's me today rather than I forgot who it was supposed to be. But anyway, I thought I'd jump in and talk a little bit about something that's been in the works for a while and that continues to be worked. And if you follow the HDF working group, that's also a topic of discussion. And sooner or later, you may actually get something in your hands, working code and something that enables you to write better applications and with fewer workarounds and so forth. But before I go there, are there any questions? Any questions about HDF or specific issues? No? Okay, then I'll jump right in. Okay, so this is something that came up many times, and my cartoon here, this is really just, I'm sure everybody has their own favorite example of dealing with sparse data, and just picture, here's like a cross-section of a house or a building, and how would you represent something like that in HDF5? Well, you could do it kind of brute force. You could just say, okay, that's probably a raster image of some sort. Just pick a sufficiently high resolution, make it a 2D raster image, and you're good to go. You could also go down the vector graphics path, and that would be fine and scalable and all the rest of it. You could also look at this as some form of sparse data set. So let's assume there's some kind of discretization, but you want to record only the pixels that are black here. Let's say this is black-white, there aren't any other colors here. You want to record only the black pixels, so to speak. So treat this raster image like a sparse matrix. And then you could come up with a sparse format of some sort. And the list goes on and on. You could also look at it as, let's call it a ragged array of intercepts. So for argument's sake, let's take this direction here at the bottom, kind of the ground floor level. And then you could sort of project these orthogonals here and then basically record the intercepts. And what you would find is that, of course, the number of intercepts will vary as you sort of sweep in this direction. But you could treat this like a ragged array of intercepts. And okay, what I would say is that all of these things can be implemented in HDF, and it really depends on, I mean, in a real application, what you want to achieve with that underlying data set. And there would be advantages and disadvantages. This is what I would call here, there would be different surprises in store here. And what I mean by that is, so for example, if you treat this as a raster image and you don't apply some kind of compression or something like that, if you scale this up, you'll be surprised how large this data set becomes very quickly, and that would be one surprise. In the vector graphics department, okay, here you might get away with rectangles and so forth, so that wouldn't be too bad. But the more of these analytical primitives you would have in your arsenal, and then the metadata tying all these things together, you can certainly represent all these things in HDF5, but then you really have to be careful of how you sort of across multiple data sets and groups and so forth, and then add some attributes and so forth, how you would represent that in HDF5. I'm not saying this wouldn't work. It would work, and it could be quite efficient and so forth, but you have to do a lot of work. That's the bottom line, is you have to do a lot of work. Likewise, with sparse data sets, can you come up with yet another optimized sparse format for this type of application? Absolutely. If sort of coordinate storage or compressed row storage or whatever doesn't do the trick, find something that's more suitable for the type of data that you want to represent, and you can represent all that in HDF5 and you'll be good. And likewise, ragged arrays of intercepts and so forth. So all of these can be done in HDF, but from a user perspective, none of these are particularly appealing in the sense of that they depart, or they are a lot of work, they depart sort of from the vanilla multidimensional array data set model that they will have gotten used to. Now, that was actually sort of considerations like this were the starting point of a discussion, and there were many discussions before that. But in 2018, Neil and John created this RFC that was called the Sparse Chunks RFC, and I have it somewhere here. So if you go to support.hdfgroup.org, releases HDF5 documentation RFCs, you will find this RFC, and there goes back to August, late August of 2018, where they describe this sparse chunks approach. And it's well worth reading. It talks more than about sparse chunks. You can also learn a little bit about how the I/O pipeline works that involves chunking and so forth. So this is all worthwhile reading, even if you're not interested in sparse necessarily. And this is also, I forgot if I believe the HDF working group recordings are public and the notes. So if you look at recent HDF working group meetings, this was a topic or a recurring topic of discussion, so you might want to catch up on that. The idea of sparse chunks is basically to say, okay, right now there's only one kind of chunks supported by the HDF5 library in the file format, and that's pretty much dense chunks. And the idea was, well, in order to maintain the API for data sets, for dense, in double quotes, data sets, was to say, well, couldn't we somehow augment how we store these sparse chunks, but then also, since we need to represent them in storage and we need to represent them in memory, we need to modify a little bit that transfer mechanism, because we would store them as the RFC suggests, basically as chunks, as dense chunks. However, these dense chunks do not represent, as the dense chunks right now represent certain sections of your data space in storage. They would really be chunks as storage primitives overlaid with selections that would basically coordinate, so to speak, the mapping between the storage space and the logical data space in the API. And so that that's a rather clever idea, and it also achieves that goal of retaining the data set semantics, in the sense that, yeah, you can do reads and writes of data sets, and if there's nothing there, you will read fill values, but then for a sparse data set, you can inquire in double quotes which locations in this data space actually contain in the sparse sense, non-zero, whatever zero means, entries and so forth, and that's great. So of course there is a danger here. The danger is that, and I did this experiment myself, if you go ahead and search for what is the most misunderstood HDF feature, or sort of where do people make a lot of mistakes in terms of using the API, it's definitely chunking, and this chunking in conjunction with compression. And so if we now double down, so to speak, on chunking, so now there are not only dense chunks, or the chunks that people are used to is the wrong word, but they maybe have read about. And we introduce these things called sparse chunks. You might guess that this is going to make matters worse. So will people use these new sparse chunks correctly? Well, expert users, power users, and so forth, I'm sure will use them to great effect and so forth. But I think there is a danger here that people will definitely be confused by this, and yeah, so that remains to be seen. On the upside, if you think about it, you can actually, the HDF data model has been pretty steady or constant. There haven't been really any dramatic changes since its inception in 1998. And what I mean by that is, if you go back to this classical paper here from 1998, and I have hyperlinks here in this document, and they are all in the, if you go to the HDF Clinic GitHub repo today, I have the references here. So if you're interested in following up on that, it's this paper here. And this is sort of a classical discussion of the data model for scientific simulations. And at the time, there was a lot of thinking about, well, yeah, there are low-level storage primitives, but then the sort of fiber bundles were the thing. And then others have run with that idea and created other implementations, such as Werner Banger with his fiber bundle approach. But the underlying idea is pretty much the same. And all these ideas go back to this paper. And but so what would happen now with these structured chunks is, if you're mathematically inclined, we would finally, so to speak, transition from fiber bundles to sheaves or pre-sheaves. And I linked if you want to read more on that, the Wikipedia article on pre-sheaves is actually very interesting. And that's where the sections come from, because unlike for fiber bundles, where you have a section is basically, in fiber bundles, you have this thing called the base space, and then you have some people call it the total space, and you have a mapping from this total space onto the base space. And if you take the pre-image of a point in the base space, this is the so-called fiber. And for a fiber bundle, it so happens that the fibers are actually all the same. And that doesn't necessarily mean that that total space is a cross product or a Cartesian product. In reality, for HDF5, that is the case. It's just what people call a trivial fiber bundle, which is just a Cartesian product of the fiber is the data type or the element type. And but now with these sparse chunks, as we call them, you get away from that model, and you have what you might call only partially defined functions. So no longer is there a requirement that you have these undefined values or these zeros, as you would call them in the sparse context. And the data type actually can vary from, in the most general case, the data type can vary from point to point. And you can have, for example, this type of multiplicity. In the case of fiber bundles, you have only one value, and the type is the same for all points in that total space. But for sheaves or pre-sheaves, as they are called, that can be generalized. Now, so that's a great thing. That would be an interesting transition that opens all kinds of new possibilities. Just representing, it's just interesting if you choose your favorite search engine and just look for images of sections or cross sections, what the variability or the variety of images that you come up with. And I think considering how important sections are as data sets in so many practical applications, I think once we get that support for sparse data in some form into HDF5, that really will be a great achievement and yeah, open up so many more interesting applications. Now, but I think we also have to think beyond that. It's sort of interesting. I think there was a follow-up paper a few years later where I think David Butler was one of the co-authors on this paper. So they I think a few years later also thought about sheaves already. They realized that perhaps fiber bundles aren't general enough to cover sort of the full spectrum of scientific applications they had in mind. But then again, this was 20 years ago, over 20 years ago. Now, looking into the present, can we see? It would be interesting, perhaps, to write a similar paper where one would discuss, because scientific simulations probably haven't changed dramatically. However, people do other simulations today, call them data-intensive simulations, or AI-assisted or AI-infused, use your favorite AI attribute, and then think about what kind of new requirements does that create for data sets. For data sets that perhaps look like multidimensional arrays, but where the mechanism to store or generate that data is different from sort of the ideas of 20 years ago. And we have seen over the past probably 2-3 years several attempts. I would call them generative data sets. And it's interesting when people say generative data sets, sometimes they mean almost the opposite things. So some people say, well, generative data sets are synthetic data that are generated by AI. Some others say, well, the generative data sets are actually the raw data that generative AI uses to create synthetic data. So it's interesting either way. It's just there are different mechanisms at work here. And but I think that there are some interesting use cases for actually for both, and we should think about how we can support this in HDF5. And there was actually a forum post a few years ago where Lucas, who at the time implemented these things that he called user-defined functions or computational data sets. I forgot which term he finally settled on, where he showed how you can use again one of these generative adversarial networks to generate synthetic data on the fly. He has an interesting example here. So we have definitely seen attempts in that direction already. And last but not least, of course, we will probably see perhaps one more or two more new storage layouts. If you want to view structured chunks as a new storage layout, then there might be others. But then, of course, with the arrival of AI, autoencoders are very popular. And we have also seen for compression methods, for example, if you look at last year's HUG, for example, we had at least one presentation, but I think there were several presentations where, in connection with compression, for example, people are looking at, rather than using sort of generic compression algorithms that have maybe standard parameters like the compression level in the case of gzip or certain table sizes for szip, they have actually used trained for that specific data neural nets that then would be stored with the compressed data so that you can decompress them. But that compression method, it's really not a method. It's a specific instance that works particularly well with this specific data set. But storing the compressed data and the training state of that neural network, you still come out ahead or better than traditional compression methods. We've definitely seen that, and yeah, so I think there might be room potentially, or it would be for sure an interesting research topic to look into, call it, yeah, storage layouts based on autoencoders, and perhaps with something like that, you could also do something for users, in the sense that, yeah, asking users to provide a chunk size is a big ask, even for experts users, I think. And various, through the use of autoencoders, perhaps, maybe there is a chance, and maybe not in all circumstances, but sometimes you can encode your data, and yeah, you don't have to think about chunk sizes or this or that. And it's for, at the end of the day, it's for machines. Of course, this raises all kinds of questions about reproducibility, longevity, and many other questions. But yeah, I think in this space there is a lot to discover and a lot to happen. And yeah, the nice thing with HDF is I think we have a pretty stable and pretty generic, well accepted, well liked API. So we can explore all these options behind the scenes, and at the end of the day, benefit users, make sharing of data more powerful and more efficient, and all the rest of it. Okay, that's all I wanted to say. But then, any questions, comments?
Gerd, when you implement, as you go with some of these implementations, is there any plan on putting any of that into preview mode so folks can get just a preliminary look at?
Actually, I wish Dana were here, but unfortunately he's out sick, and I'm sure he could speak to that. I would imagine that there would be, if there is ever something that eventually we want to release, that there would be some kind of a beta version, or and yeah, if you compare the discussions in the working group with what's in this RFC, I mean, there is a description. I mean, there aren't that many new API calls, but if you read this RFC, there is a proposed API in here, and I think the API actually has changed quite a bit since this RFC, but you get sort of the idea of what that would look like. And the good news is maybe there's a handful of new calls, mostly yet another property list or other property lists and so forth. But by and large, the API is pretty much unchanged. So the good news is you can take advantage, if there were a pre-release or something, you can take advantage of these without too many code changes. But yes, to your question, no, I don't know what specific plans there are. But yes, I would imagine that if we are thinking about putting this into some release, that there would be either a snapshot or a beta version at some point, or an alpha, or and of course with HDF 2.0, the versioning, I think, is going to be a little more sane anyway.
There's interesting background here, Gerd. Was there another capability or other extension that you were considering as part of the discussion?
Well, I mean, you mean with sparse specifically, or with like generative?
I'm thinking more possibly the generative notion.
Yeah.
Except it couples, the risk with that has always been that it would couple a file to some form of an executable, explicitly or implicitly, whether we tried to store some interpreted script and potentially bundle the interpreter with the library too, which is rather large. Otherwise, you lose a lot of the, so to speak, portability of the data, because you can't generate it anymore once the executable can't be executed. I don't know.
Yeah. And I mean, it's not, this is obviously not a replacement for all use cases, so to speak. But definitely, I mean, definitely, I think generative data sets, for example, in the sense of synthetic data, have a place for many applications. For testing, for example, you create all kinds of test patterns, the same way you do unit tests with software. You have, whether you are developing a CFD code or something, you create synthetic data where you know exactly what the answer should be, at what level of precision, and so forth. And if that data set is very large, and you could replace it by something that generates the data, so to speak, on the fly, and you don't have to store anything or only very little, that's a win. But then also look at lossy compression, for example. Lossy compression, and you think about GANs, for example. Well, how do you distinguish between sort of a high quality generative data set from a lossy compressed data set?
Yeah, I was going to make that analogy as well.
Yeah,
right?
yeah. But
I
then
suppose the code we're depending on then is the lossy decompressor, roughly equivalent.
Yeah. But to your earlier point, Lucas definitely has explored this idea of a fallback of a fallback in the sense that yes, you can embed in the data set, for example, like a virtual machine, almost like Kimu or something like that. And I think he even gave a demo that showed exactly that as part of reading the data set, you would fire up a virtual machine that then sort of executes the code that hasn't changed or that won't change and gives you sort of that value, that data.
Yeah, the VM versus interpreter is a blurry line, I would agree, right?
Yeah. But then also the raw data of generative AI, I think is, when it comes to reproducibility, provenance, and so forth, how the chain, the data provenance chain needs to be enriched to, provenance is not a new thing, but I think it gets added interest and complexity and so forth with the presence of synthetic data, deceitful in some cases or deceivingly realistic, whatever that means for your particular application. And then how do you go back to the raw data, or how do you distinguish raw data from not raw data, whatever that means. But then also autoencoders. I think and it's really more to scratch engineers' itch, is to say, well, can we create autoencoders that do as good a job or better a job in encoding data than sort of deliberate designs by software engineers. And but as you say, there is then this question of dependence on environments. Is it reproducible? There are a lot. How do you ensure data integrity? And there is a lot of research here, I think. Okay.
Interesting.
But I think sparse plus multiplicity, I think, will be a big step forward. But then, unfortunately, that's not the end of it. I think it will. There will be.
Well, like mathematics, we're going to have an infinite upward level of abstraction.
Yeah. Okay, if there are no other questions, thanks for coming. And I really recommend reading these, especially this is such a seminal paper. If you're interested in the early history of HDF5, this was kind of the blueprint. Would be too much, because writing real code and real software is another thing from just having ideas about mathematical abstractions. So, but nevertheless, it's amazing that all these ideas were there back when, and of course at this point HDF5 library wasn't quite 1 year old, but almost.
Well, we were part of those meetings from the very, very beginning. So I think we go back even earlier. Well, we were 2-ish years old by that point. So
Okay, cool. Thanks. Okay, cool. Have a good one. Oh, by the way, I think, Lori, did we decide the 26th is unfortunately off because of vacations and maybe, although some people probably have nothing better to do on the 26th to enjoy HDF.
Yeah, but no, call the doctor on the 26th. I think it'll just be easier for us staffing wise, and then we'll probably have to talk about the week after, but
are we talking about actually the 23rd?
Probably. Okay, I'm
sorry.
getting my
No,
meetings
I'm
mixed
wrong.
up
I'm
here.
off by week 2 or off by day 24th.
Okay.
Oh,
Yeah,
sorry. Yes, yes. The 24th. Yeah.
yes, for sure. And then no working group on Thursday, the 26th.
Yeah. Okay. That makes good
Yep,
sense.
I was using the wrong dates there. Okay. Yep, thank you, everyone.
Thank you. Bye.
Bye.
But